Welcome to Math 31. This is a lesson, a continuation of the lesson that we had started earlier, where we're looking at the slope of the tangent line. So this one we will just be doing a few examples of tangent line questions. It's slightly more complex than the previous one, but the same principle exactly. So we want to find the slope of the tangent line to f at x is equal to 1 over x minus 2 at any point x comma f at x. So this is a reciprocal function. Graphing it, it would look like this. And again, here, stop me and go through the question on your own if you're comfortable with it, and then check your answer. So we do the same thing. We work with this formula for the derivative by first principles. M is equal to the limit as h approaches 0, f at x plus h minus f at x all divided by h. It's always going to come down to that. And you don't need to write this separately. I will for this question at least. F at x is equal to 1 over x minus 2. So f at x plus h is equal to 1 over x plus h minus 2. So our simplification would be m is equal to the limit as h approaches 0 of 1 over x plus h minus 2 minus 1 over x minus 2, and all this is over top of h. Now we're subtracting two fractions on the numerator, and anytime you get into that unfortunate position, it means you have to get an LCD, a common denominator. So the limit as h approaches 0. Our common denominator, don't try to get too fancy with this. It's just going to be the product of the two factors, x plus h. Oops, I'm having a rough day here. I'm just going to get rid of this whole line here. Sorry about that. M is equal to the limit as h approaches 0 of our common denominator, try again, is going to be x plus h minus 2 multiplied by x minus 2. So just the product of the two. You cannot multiply x minus 2 by anything to be equal to x plus h minus 2. And then we take care of the numerators. The 1 over x plus h minus 2 needs to get multiplied by x minus 2. That bracket doesn't matter. The second one it does, though, because the 1 over x minus 2 will get multiplied by x plus h minus 2. And then all this is over h. So it's a little messy looking for now, but as you go deeper into the expression, you will see some significant cleaning up. X minus 2 minus x minus h plus 2 when that negative gets distributed through. And then this is over x minus 2 times x plus h minus 2. Rewrote it in a different form, but no big deal. All over h. And we have come to expect these cancellations, and correctly so, because you should in fact be canceling them out so that we are able to cancel that factor of h on the denominator. So now this expression looks like m is equal to the limit as h approaches 0. We have negative h on top, and then on the denominator x plus h minus 2 multiplied by x minus 2. It's divided by h, so it's multiplied by 1 over h. And there's our cancellation. h's divide out, so m is equal to the limit as h approaches 0 of negative 1 over x plus h minus 2 multiplied by x minus 2. We now take the limit. And if you take the limit, h gets replaced with 0. So this becomes negative 1 over x plus 0 minus 2, which is just x minus 2. And then that's multiplied by x minus 2. So that's squared. So here's our formula. Or if you prefer, and what you're going to start working with almost exclusively, f prime at x, the derivative, is equal to negative 1 over x minus 2 squared. So this is a formula to find the slope of the derivative. A general formula that will work for all points on that curve. And then it gets better. As we go to the next one, we now want to find the equation of the tangent line at x is equal to 1. So right there. So the tangent is really roughed in. I didn't do a great job of drawing it, but it is somewhat close. And we've got to be careful now, because this question wants the equation of the tangent line. Now we already know that the slope can be found by using this formula, negative 1 over x minus 2 squared. So we want to find the slope at x is equal to 1. So all we need to do, sub in, f prime at 1 is equal to negative 1 over 1 minus 2 squared. So negative 1 squared is 1. So we end up with f prime at 1 is equal to negative 1 over 1. So just plain negative 1. So therefore, the m is equal to negative 1. Kind of looks right on the graph. The scale is not 1 to 1, so be careful. And now the next thing is, to find the equation, we need to remember that we use the slope y-intercept form. So y is equal to mx plus b. So that means we've got the slope, but we need to know what point it passes through. Now the point is x is comma 1, but we need to find the y point. And this is where you got to be careful. To find the y point on the original curve, you need to go into the original function. F at 1 is equal to 1 over 1 minus 2. So it's always the original function that will supply you with the ordered pairs. So f at 1 is equal to negative 1. So therefore, we have a line with a slope of negative 1 passing through the point 1 comma negative 1. The rest should work well. Plug in our y is negative 1, plug in your m is negative 1, plug in your x is 1, and then plus b, and then solve away. And you will get b is equal to 0. So therefore, y is equal to mx would be negative 1 or negative x. And amazingly, that's what we have pretty much by inspection. I actually eyeballed that one, but I either got lucky or I did a good job because the y-intercept is equal to 0. So read those questions carefully, so make sure that when they ask for the equation that that's what you give them. Let's do one more. Find the slope of the line tangent to this radical function, square root function, at any point. So this is what the equation looks like. And for your information, at any point would mean we'd want to get the slope there, or there, or there, at any point along there. And the formula we get will be a general one. It'll work for all of those, so we can find anything we want. So to do that, we remember this very important formula. The derivative is found by taking the limit as h approaches 0 of f at x plus h minus f at x all over h. So then the limit as h approaches 0, let's be real careful with this one, f at x plus h is going to be the square root of 2 minus x plus h, and then minus f at x is the root of 2 minus x. So be careful. You had to replace the x with x plus h all over h. Now we know where this one is going. And it's up to you. But I'm going to clear up that little bracket. You don't need to do that. But I'll write this as 2 minus x minus h minus 2 minus x square root over h. And you're probably thinking the same thing that I'm thinking, that we need to multiply by the conjugate to rationalize the numerator. So let's do that. Now I'll have to write this down below, but I think I'm okay. The limit as h approaches 0. The root of 2 minus x minus h minus root 2 minus x over h multiplied by the conjugate, which is the root of 2 minus x minus h plus square root of 2 minus x. Two minus x minus h plus root of 2 minus x. A minus b times a plus b is always a squared minus b squared. So when we multiply those together, I'm going to go directly to 2 minus x minus h minus 2 minus x. And then that's on top. Our denominator is h multiplied by the root of 2 minus x minus h plus root 2 minus x. And this would be the limit as h approaches 0. So now I'll bring up a new screen. We'll mop that up. I'm really hoping that we're going to get a simplification on top. So this will give us the limit as h approaches 0. These take a lot of space in case you haven't noted that. So we have 2 minus x minus h. Then when we distribute that through, we get minus 2 plus x. And then the denominator is h, and then bracket 2 minus x minus h plus root of 2 minus x. So the x's do cancel, the 2's cancel, and in fact we'll get this. You can do this directly if you prefer. Negative h over h times the root 2 minus x minus h plus square root 2 minus x. h's divide out, leaving you with negative 1. So the limit as h approaches 0 of negative 1 over the root of 2 minus x minus h plus the root of 2 minus x. So now when we take the limit, we replace the h with 0 and we get negative 1 over the root of 2 minus x plus the root of 2 minus x. So therefore, the derivative, or the slope, or a formula for the slope, can be written as negative 1 all over. Now those are like radicals, so that is actually 2 root 2 minus x. So that's how it's done. A little more complicated, but it worked basically the same way. So this is the end of this unit. Next unit will be the derivative, where we take this first principle method, learn some notation, and go a little further with it. Thank you for your time.